After traveling the globe, ALMA's state-of-the-art antennas end up here, in one of the most desolate landscapes on Earth. Chile's Atacama Desert is quite literally a land of extremes. Temperatures fluctuate from -20 degrees Fahrenheit at high altitude to 105 on the desert floor. It's not uncommon to experience deadly sun and chilling snowstorms in the same day. This unique environment presents challenges for both ALMA's sensitive machinery and its workers.
The atmosphere is roughly half what it is at sea level, so you have half the oxygen. So manpower tends to suffer from oxygen deprivation or hypoxia. They tend to be lightheaded, they tend to be nauseous, and they're more subject to injury or accidents at that high site.
This is a critical time in the project's final stages. Tomorrow, the first North American antenna is scheduled to be moved from ALMA's Operations Support Facility up to its final destination, the 16,400-foot high site on the Chactantor Plateau. It's a painstaking procedure that has been planned and simulated for more than a decade. For the antenna's technicians, it's an exciting, nerve-wracking countdown to either sweet success or debilitating failure.
Barring anything that is just an absolute unknown out of left field, I think we should be able to bolt the antenna down. The one challenge that we have no control over is going to be the weather, the wind, and the chance of a snow out and we get halfway up the hill and we've got to either park or turn around and come back.
At the relative safety of the low site, Brian and his team perform critical tests to make sure no mistakes happen on transport day. The success of the move hinges on the connection between the $5 million antenna and the specialized transporter that will haul it into the high desert. The cryogenic receiver systems cannot lose power for even a few seconds, or their temperature will rise, and the antenna's sensitive electronics could be damaged. Driver Luis Roa uses remote control for the precise lifting work. He plants the transporter to the ground to raise the 115-ton antenna. The antenna is designed with perfectly balanced lift points where the transporter can lock on. With all connections secure, all that's left is the critical power transfer. The antenna's systems are safe, but power is not reaching the main receiver cabinet. Without this connection, the antenna's emergency stops, the only way to manually cut power to the transporter in case of a mishap, will not function. 5 hours later, Brian's team is almost a half day behind schedule, and important vibration tests have yet to be performed. The entire project team meets to discuss the situation.
We don't have communication between the transporter and the antenna.
The consequence of that?
In the case of a fire or something, we don't have any signal to the antenna, to the transporter.
If there is a fire, are we going to get some alarm going off somewhere?
It's a serious problem.
The current standing of the project is that...
With the clock ticking, the team makes a difficult decision. They'll proceed as planned. While engineers battle technical problems, the merciless desert is beginning to make its voice heard. 60-mile-an-hour winds have been forecast for the following afternoon. If they're able to get the antenna moving, it must be on schedule, or extreme conditions at the high site could endanger personnel and equipment and force them to scrub the mission. With only 12 hours to go until the historic move, the situation is far from certain.